However, it is used for classification problem in machine learning. Generally, we are using this for classification problems. The SVM chooses the extreme points or vectors that help in creating the hyperplane. The SVM algorithm helps to find the best line or decision boundary. It is called as hyperplane. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start discussing about the unit Learning and Machine Learning, and in this session, let us discuss about support vector machine algorithm. Now let us see the definition of this. So what is support vector machine algorithm? So it is SVM or support vector machine is one of the most supervised learning algorithm. You know what is supervised learning? So it's the algorithm which is used for classification as well as regression problems. You know that in supervised learning there are two categories, classification and regression, and this support vector machine algorithm is used for both the application. One is for classification as well as regression problems. However, it is used for classification problem in machine learning. Generally, we are using this for classification problems. And the goal of SVM, that is support vector machine algorithm, is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. So the main purpose of this algorithm is this one. So what is the goal of this? Here we have to create the best line between the two categories. If there are a group of data, so we have to segregate it with a definite line. We have to segregate this with the best boundary line. So what is the meaning of this? So here we are separating the given data into different groups, or we can say into different classes. So any new data which are entering to the data set, so that can be placed between any of the category which belongs to. So that is the main aim of this support vector machine algorithm. So the best decision boundary is called hyperplane. So we are going to separate the given data set into two different categories, or we are separating them through a boundary line, and that boundary line is called hyperplane. So hyperplane is the boundary is going to separate the given data set into or segregate into different classes. That is the definition of support vector machine algorithm. In the next slide, the SVM chooses the extreme points or vectors that help in creating the hyperplane. Now look at the diagram here. So this is a schematic diagram how we represent support vector machine algorithm. So here this is the hyperline, and this is I'm talking about the hyperline. The hyperline, what you have seen in the previous slide, it is going to separate the two sections or into given data into two different classes. If you look at this diagram here or the graph, you can make out that this is one set of data with the circles, and this can be another set of data, or it can be in the form of a square or rhombus. And these two are the data sets and are separated through a line. Is called a boundary line, that is called hyperplane. This is the definition of support vector machine algorithm. So here it helps in creating the hyperplane. These extreme cases are called as support vectors or support vectors. In the above diagram, in which there are two different categories that are classified using decision boundary or hyperplane. If you look at the diagram here, these are the two different data sets are separated by a hyperplane. And here what is the meaning of this? Support vectors. Extreme cases are called support vectors. If you observe this here, see, it is possible to segregate this with number of lines. We can draw here number of lines, but here we are considering the one line, the dotted line here is going to touching this point of this set here, and on the other side this is the dotted line. This is one more vector, that is what I call support vectors. This one more support vector which is just touching one of the element or data in this data set. And here if you observe this, and these are the difference between the two data sets, and here we can draw or we can find out the best boundary line between these two, that is called the hyperplane. See, that is the main purpose of the support vector machines. We are used to segregate the given data set into two different classes. That's the definition of support vector machine algorithm. Now let us see in the next slide types of SVM. So generally there are two types. One is linear SVM. So what is linear SVM? It is used for linearly separable data, which means if a data set can be classified into two classes by using a single straight line, then such data is termed as linearly separable data, and the classifier is used to call it as linear SVM classifier. So what is the meaning of this? So as per the definition, so it is possible for us to separate two different classes easily by drawing a vertical line or by drawing a line. If you look at the previous diagram here, see in the data set given, so we have separated, or it is possible to separate these two data sets as two different classes. It is easy for us. So in this is an example for linear SVM. That is the definition of linear SVM. Second one is non-linear SVM, support vector machine. It is used for non-linearly separate data, which means that data set cannot be separated or classified by using a straight line. So then such data is termed as non-linear data set, and it is non-linear SVM classifier. So here non-linear data in SVM. So as per the definition, it is possible to separate the given data set into two or three classes by drawing or by finding one boundary line. So it is not possible to segregate with one straight line. So those type of data sets or SVM are called as non-linear. So in linear SVM, as we have seen in the previous slide, in the diagram, it is possible for us to separate two data sets into different classes. So this is the difference between linear and non-linear SVM. In the next slide, let us see some technical terms what we use in SVM. So here one is hyperplane. Already we have learned in the previous slide what is the hyperplane. See, there can be multiple lines, decision boundaries to segregate the classes in n-dimensional space. But we need to find out the best decision boundary that helps to classify the data points. The best boundary is known as hyperplane of SVM. Now we know the definition of hyperplane. So what is the definition of this? So it is the line which is going to separate two data set, or is going to separate the given data set into two different classes. But it is also possible to separate the given data set with multiple lines. Now if you look at the example here, So here we have drawn one line, a dotted line, one hyperplane, and also it is also possible to segregate in different line, or it is possible to segregate into different classes of the given data set. That is the meaning of multiple lines. It is possible to separate two given data set into classes with multiple lines, but the concept is we have to select the best boundary line among multiple lines. That is the definition of hyperplane. So we have to select the best line or best boundary line, that is hyperplane. Now dimension of the hyperplane depends on the feature present in the data set, which means if there are two features as shown in the image. Look at this diagram here. Then hyperplane will be straight line, and if there are three features, then hyperplane will be in two-dimensional plane. Again, the boundary depends on the dimension. Suppose if the space is two-dimensional space, it is possible to work with a single boundary. But if it is the data set is with the three features or with three dimension, then we have to follow another algorithm. See, this is the meaning of this second point here. Next one is, we always create a hyperplane that has maximum margin, which means the maximum distance between the data point, two different data points. So we have one more, what is called margin. What is the margin here? It has a maximum margin. Then only it is possible to get the best, the definite or the best hyperplane. So now in the next slide, we will see what are support vectors. What are support vectors? The data points or vectors that are closer to the hyperplane and which affect the position of the hyperplane are termed as support vectors. So since these support vectors support the hyperplane, it is called as support vector. So here we are going to draw a support vector, is going to help to find out the best hyperplane. Then what is the margin? The distance between the vectors and the hyperplane is called a margin. One of the definition is margin. The goal is to maximize this margin. So if you look at the diagram here, the same diagram, see here, if you observe this, this is the dotted line. This is called one super vector, where is going to touch or is very close it. That is the meaning of the closer to the one data point. So this is one super vector, and on the other set of this you can see, so this dotted line is very close to this data set. So these two are called as super vectors. Similarly, you can also have number of super vectors. But what is the margin? The margin is nothing but the distance between the two. So from here to here, from this point to this point, this point to this point, that is the meaning of, that is the definition of margin. That is called margin. And all these dotted lines are nothing but super vectors. And the best among the, we have to select the best boundary line in between these two, that is hyperplane. So here we are learning the three definitions. One is margin, super vector and hyperplane. So this is an example for two-dimensional image or space. It is a two-dimensional space, x1 and x2, or you can take it as x and y axis. This is a two-dimensional space. Now in the next slide, now let us some example here. What is the example for support vector machine learning or algorithm? Now, suppose we see a strange cat that also has some features of dogs. So if we want to a model that can accurately identify whether it is a cat or a dog, so such a model can be created by using the SVM algorithm. See, this is one of the examples. Now look at the diagram here. So in this one, so here as per the definition, we have the model here. One model is here. We are going to predict it, and this is the output of this. So as per the definition of, as per the example here, so here this model is developed based on two factors. One is a cat and one is a dog. One is cat and one is dog. And this model is prepared with the features of cat as well as features of dog here, and that is a model. So with the help of this model, suppose if we get one of the new data or one more new creature which has few qualities of dog and few qualities of cat. In that case, if we give this one as new data as an input, so our purpose is, so this particular data should go to any one of the classes. Here if you assume that this is cat is one class and dog is another class. That is the purpose of SVM. It's going to segregate into two different classes. In this example, cat is one class, and here dog is another class. So any new data gets into that, enter into the model. So this model clarifies that, and with the help of the features entered in the model, or with the help of the features available in the model, is going to put this new data into any one of the category. That is the purpose of this SVM, or support vector machine algorithm. In the next slide, what is the working of linear SVM? Now let us see, we have learned there are two type of SVM, linear and non-linear. Let us see what is linear. So it can be understood by using an example. Suppose we have a data set that has two tags, green and blue. This is an example here. This is a green and this is a blue. And the data set has two features, x1 and x2. So this is, you can take it as x1 and this is x2 data set, or we can have two-dimensional data set and classifier that can classify the pair x1 comma x2 of coordinates in either green or blue. So here there are two data sets and it has to be separated with hyperplane, and in this one x1 x2 are the coordinate value, and we can assume that this can be a two-dimensional space. So in this one, so this is the definition of the example. In the next slide, so it is a two-dimensional space, as I told you in the previous slide. Using a straight line, we can separate these two classes. So this is simple. If you look at the diagram here, we can draw a line like this or like this, and this is is it possible for us to separate two different classes with one or multiple lines. And here, but there can be multiple lines that can separate these classes, as you can see in the example. In the next slide, the SVM algorithm helps to find the best line or decision boundary. It is called as hyperplane. So in the previous slide, you have seen that. So here, in this one, we can find out which is the best boundary or which is the best line is going to separate these two different classes. So here we have to select this. Then what is the procedure for that? So if you look at the definition here, it finds the closest point of the lines from both the classes, and these points are called support vectors, and the distance between the vectors and the hyperplane is called margin. Same definition also we have explained in our previous slide with the diagram. And the goal of SVM is to maximize this margin, and the hyperplane with the maximum margin is called the optimal or best hyperplane. Now look at the example here now. In this example, as we've seen that there are two different classes here. So this is super vector. So this is a super vector is a line very closer to the one class, and this is another super vector very close to this class or is passing on this data set. And here, which is the best? So here now, if this is the hyperplane, it has been found out with the help of the model given. Now, if you look at this is called margin. This is called our margin. So here we have to select the best boundary line by looking at the margin. So whenever there is a maximum distance between these two super vectors, we have take it as a boundary line or hyperplane. So this is super vector, margin, super vector, and with the help of this, it is possible for us to find out the optimal hyperplane or best hyperplane. In the next slide, let us see what is non-linear SVM. So here, if data is linearly arranged, then we can separate it by using straight line, what you have seen in the previous slide. But for non-linear data, we cannot draw a single line or single straight line. Look at this example now. In the example here, see there are blue data set or a blue color tags and a green color tags. Now, how can we separate this into two? It is very difficult for us to separate two data sets by using a single or multiple straight line. So this is an example for multi-dimensional or three-dimensional. It is not two-dimensional space. So how do we go about it? In the next slide, we will see. To separate these data points means the data points what you have seen in this example here, you need to add one more dimension. So as I told you in the previous slide, it was two-dimensional space. Now it is one. We have to add one more dimension to this. So for linear data, we have two dimension x and y. But in non-linear, we have to add one more dimension, that is z. Now look at the diagram here. So this is x plane, this is y, and this is x, and this is z. So here you can make out there are three-dimensional or three dimensions. So it is an example for three-dimensional workspace. So now it is non-linear SVM. So it can be calculated as z equals. So z equals x squared plus y squared. This is the formula to find out the value of z. By adding the third dimension, the sample space will become like this. So now by using the third dimension z, so we can see that we can visualize this picture like this. Now if we compare this with the previous one, see this is with the help of two-dimensional. By adding one more dimension to it, it is possible to separate this like this, or we can visualize in this picture. So this is by adding z or one more new dimension. Now in the next slide we will see. So here it is possible to divide the data set into two classes in the following diagram. So after using or adding one more dimension z, it is possible now is it possible for us to separate data sets into two. So here it is possible to find out again the best hyperplane between the two different classes. So this is an example for nonlinear SVM. Here we get the circumference of radius 1 in case of linear data structure. So it is how this is another method. We can separate the given two data set by using a three-dimensional workspace. So in this example, it is possible to get the circumference of radius 1. So this is nothing but the best hyperplane for this diagram or for this example. Students, so far we have discussed about support vector machine algorithm. Let us continue our discussion in my next session. Thank you very much.